niggas come to me where I said, okay, this motherfuckers where they come in like some situation where you just pick up with where it's just like, okay, you excited about it. I was like, now come fuck that. He was like, hey man, you said that was I want to get some say this is we're basically trying to say yeah, I can't pick him basically. Or then him and not him, but then like shit, it's kinda you can tell but it's like shit. So you can't but you just what I'm saying, you can't be one or the other word shit. Fuck man, just say the man, they just like, hey, fuck this shit, man. This is just trying to do anything shit. Anything saying basically like leisure time or some shit like that, or you know what I'm saying, you supposed to just like a day off or some shit like that, you know. It's like some bullshit or shit. He's supposed to be like, all right, say, hey man, what's wrong with you? Yeah, what's up, bro?
In this video, we're going to talk about the centripetal force. When you hear the word centripetal force, what do you think about? Now, before we talk about it, let's go over a few things. So let's say if we have an object that is moving to the right, and a force is acting on the object in the same direction as the velocity vector. What's going to happen to the object? If the force and velocity vectors are in the same direction, the object's speed will increase. It's going to speed up. Now, what if the force vector?
No, I'm doing this for
Were you recently injured in a car accident?
Trying to stick to equation where
in this video, I'm going to review
you got a lot of fucking
some of the most common formulas that you're going to encounter in
ads and shit.
physics
I
1 class.
don't know what shit down.
So whether if you're studying for physics now or if you're going for a final exam, this video is going to be very helpful to you. So the first formula you want to know has to do with motion with constant speed, and that is d is equal to vt. Now you could read this as displacement is equal to velocity multiplied by the time, or distance is equal to the speed multiplied by the time.
Let me do this one first.
In this video, we're going to go over some equations that you need to know to solve projectile motion. So let's review some basic kinematic equations. Whenever an object is moving with constant speed, displacement is equal to velocity multiplied by time. Now, when an object is moving with constant acceleration, there are 4 equations you need to know. The final speed is equal to the initial speed plus the product of the acceleration and the time. There's also this equation. The square of the final speed is equal to the square of the initial speed plus 2 times the product of the acceleration and the displacement. Displacement is equal to the average speed, which the average speed is basically the sum of the initial speed and the final speed divided by 2 multiplied by the time. As you can see, the third equation that I listed here looks like the first equation for a constant speed. Okay, I did not want to do that. So I can rewrite this equation like this. V average times t, where V average is initial plus final divided by 2. Now there's another equation that you need to know. D is equal to V initial t plus 1/2 AT squared. So make sure you know that equation too. So what exactly is D? You can use D as displacement or distance. Distance and displacement are the same if an object moves in one direction and doesn't change direction. If it changes direction, then displacement and distance is not the same. But technically, D is displacement. Displacement is basically the difference between the final position minus the initial position. Now, you can use displacement in the x direction, or you can use it in the y direction. So just keep that in mind. Now, there's 3 types of shapes for projectile motions that you need to be familiar with. Let's say if we have an object and it comes off a cliff horizontally and then eventually hits the ground. That's the first type of trajectory you're going to be dealing with. So what equations do we need for this situation? The first equation that's going to help you is this. H is equal to 1/2 AT squared, where H represents the height of the cliff and T is the time it takes to hit the ground. This equation comes from this equation. D is equal to V initial T plus 1/2 AT squared. Now, when you're using these equations, you need to ask yourself, am I dealing with the X direction or the Y direction? You got to separate X and Y for projectile motion problems. We're going to apply this equation along the Y direction. So this is really dy is equal to Vy initial times T plus 1/2 Ay times T squared. Dy, the displacement in the Y direction, is basically the height. So that's H. Vy at the top is always 0 because the object is moving horizontally. The initial speed of the ball is Vx, not Vy. And so we get this equation. So H is equal to 1/2 AT squared. So let me just redraw this picture. So make sure you know the first equation that we just mentioned. Now, in addition to knowing this equation, which if you know the time, you could find the height of the cliff, there's also another one. We know that D is equal to Vt. This is the range of the graph, the distance between where the ball lands and the base of the cliff. Now, if we apply this equation in the x direction, the displacement in the x direction is the range. So we can say that the range is equal to Vxt. And for this type of trajectory, Vx is the initial speed of the ball. So that's how you can calculate the range. If you have the range, you can find the time, and then using the time, you can find the height. So these are the two main equations that you'll need for this particular trajectory. Now there's some other equations. Sometimes you got to find the speed of the ball just before it hits the ground. Whatever Vx was at the beginning, Vx will be the same. For projectile motion problems, Vx does not change. The acceleration in the x direction is 0, so Vx is constant. The acceleration in the y direction, that's the gravitational acceleration, it's negative 9.8. And so Vy changes. To calculate Vy, we can use this equation. V final equals V initial plus AT, but we're going to use it in the y direction. So we know that Vy initial is 0. At the top, Vy is always 0. So you could find Vy final using this equation. Now, to find the speed of the ball just before it hits the ground, you need to use the horizontal velocity and the vertical velocity. And if you need to find the angle, you can use this equation. It's inverse tangent Vy divided by Vx.
Did you know that your insurance company doesn't actually want you to know about this?
So you said you were recently in a car accident, right?
Yeah.
You got $160 grand off of that?
Yeah, it's pretty nuts. I mean, lots of people unfortunately don't know how much money they can actually claim from their injuries and car accidents. I mean, you can be owed
They really know, but we're not fucking.
Now, the second type of trajectory involves this type of fixture. So let's say if we have a ball and we kick the ball from the ground, it goes up and then it goes down. So that ball is going to have an angle theta relative to the horizontal, and it's going to be launched at a speed v. This is not Vx or Vy, this is v. Now let's draw the vector v. So here's v, and here's the angle theta. V has an x component and it has a y component. The x component is Vx. The y component is Vy. So Vx is equal to V cosine theta, and Vy is equal to V sine theta. And V, as we mentioned before, is the square root of Vx squared plus Vy squared. And if you want to find theta, it's inverse tangent Vy over Vx. Now let's define this as point A, point B, and point C. What is the equation that we need to calculate the time it takes to go from A to B, or to reach the maximum height, which is at position B? How long does it take to go from A to B? Now, to derive that equation, we need to start with this equation. V final equals V initial plus AT. But we're going to use it in the y direction. So this is going to be Vy final equals Vy initial plus AT. At the top, that is at position B, Vy is always 0 because it's not going up anymore. So B is the final position, A is initial position. So Vy final is 0. Vy initial is basically V sine theta, as we wrote it in this equation. Acceleration in the y direction is basically g. So solving t, we need to move this term to the other side. So negative V sine theta is equal to gt. And dividing both sides by g, we can see that t is equal to V sine theta over g. So that's the time it takes to go from A to B. The time it takes to go from A to C is twice the value. Notice that the graph is symmetrical. So if it takes 5 seconds to go from A to B, it takes 5 seconds to go from B to C. And so to go from A to C, it's 10 seconds. So the total time is just 2V sine theta divided by G. If you're wondering what happened to the negative sign, know that the G is negative 9.8, so it cancels with the negative sign. But if you plug in positive 9.8, you don't need the negative sign anymore. Either case, time is always positive, so just make sure you report a positive value for time. Now, let's talk about some other equations that relate to this shape. How can we derive an expression to calculate the maximum height between position A and position B? So going from A to B, let's use this particular kinematic equation. V final, or Vy final squared, is equal to Vy initial squared plus 2 times Ay times dy. So you've seen it as V final squared equals V initial squared plus 2AD. I simply added the subscript y to it because the height is in the y direction. Now at the top, Vy is equal to 0. So position B is the final position. So Vy final is 0. Vy initial, we know that Vy is V sine theta. So Vy squared is V sine theta squared. And of course we have plus 2 times the acceleration in the y direction is g. The displacement in the y direction is the same as the height. So we can put h at this point. So let's move this term to the left. So negative V squared sine squared theta, if you distribute the 2, is equal to 2gh. So now let's divide by 2g. So the maximum height, if we ignore the negative sign, is V squared sine squared theta over 2g. So that's how you can find the height if you have the angle theta and the velocity, not Vx or Vy, but the velocity V. Now, what equation can we come up with?
I'm about to cash this check for $50,000 for an accident I was involved in over 5 months ago. The same accident that the insurance company told me.
Now, what equation can we come up with in order to calculate the range? how can we derive an equation to find a range of the graph? What equation would you use? The range is the horizontal distance, or the horizontal displacement of the ball. Now we said that the range is equal to Vxt. And you could find Vx by using the fact that Vx is V cosine theta. Now the range is the horizontal displacement from points A to C. What is the time from point A to C? As you mentioned earlier in this video, the time it takes for the ball to go from A to C is equal to 2V sine theta divided by G. So we have V cosine theta, and we're going to replace T with sine theta over G. Now V times V is basically V squared. So we have V squared times 2 sine theta cosine theta divided by G. Now there's something called a double angle formula in trigonometry, and here it is. Sine 2 theta is equal to 2 sine theta cosine theta. So therefore we can replace the expression 2 sine theta cosine theta with sine 2 theta. And so therefore the range is V squared sine 2 theta divided by G. So that's how you can derive an equation for the range if you have this type of trajectory. Now the third type of trajectory that you're going to see involves a ball being launched at an angle from a cliff or from some elevated position above ground level. So it's going to go up and then it's going to go down. So H is the height of the cliff, and R, once again, the ball. Let's call this position A, position B, and position C. So one of the first type of questions that you might find with this type of problem is calculating the graph going from A to C. Now this graph is not the same as this trajectory, where the time it takes to go from A to C is 2V sine theta over G. If you use this equation, that'll give you the time it takes to get to this position, which is symmetrical to A, so don't do it, it's not going to work. So therefore, we need to do something else. It turns out that there's another way to calculate the time. I'm going to show you two ways, so please be patient. Let's start with this equation. Displacement is equal to V initial t plus 1/2 at squared. But we're going to apply it in the y direction. In the y direction is the difference between the final position minus initial position. And then V initial, but in the y direction, is Vy initial. Acceleration in the y direction is basically 9.8 or G. So moving this term to the other side, perhaps you've seen this equation. Y final equals Y initial. Y initial is basically the height of the cliff plus Vy initial t. Remember, Vy initial is the V sine theta. Theta is the angle above the horizontal. Plus 1/2 gt squared. Now to find the time it takes